Meanwhile, I request Annu. So let me introduce my team over here. Here we have Annu over here only. So Annu is my PhD student who is working on development automatic system for telecast of news for deaf people. So basically, this is the project that Vinod and his team is going to develop. That will be the byproduct of that project. So Anu, can you unmute yourself? Anu?
हाँ जी, हाँ जी। गुड आफ्टरनून सर।
Yeah, good afternoon, Anu. So this is the team from Thapar University who will be working on the project that Jaswinder and Rohan were working on. So can
Yes.
you just start with what you were working on and how you have converted, you have downloaded the DD News and then converted into the frames and all. So in the meanwhile, Jaswinder will be joining us.
Yes. Good afternoon, everyone. Uh, Sir, we are working on translating news into ISL, Indian Sign Language, using synthetic animations. Sir, first we downloaded the news with the help of subtitle with the help of subtitle software. uh, when we downloaded the news, we have faced the problem like the words are joined, like this is these words are joined. We firstly we separate these words to make a proper spaces, and then we make the unique words from the paragraph news using unique word softwares, online softwares, and find the frequency of each words, how many times these words are occurs in the news. And then with the help of the news translator Krishma, we have translated these unique words into ISL. ISL RTC made the ISL dictionary. This dictionary consists of only 6,000 words. We have used these words also that are used in news. And after the conversion of translate these words into Krishma videos, we will translate these human video into ISL using synthetic animation videos using the Hypnosis software tool. This Hypnosis software will convert the human video into synthetic animations. But problem with this software is that we need a lot of time, because this is a very complicated task to convert the human video into SIZML notation. For this, we have a software Hamburg notation system. Dr. Lalit Goyal and Dr. Vishal sir have developed a tool to translate human videos to SIGML.
Yeah, it is visible.
Sir, this is an offline tool. Sir, in this system, we can show manual and non-manual features of the video. For the manual features, like these are hand shape, like fist, hand shape, one finger, two finger, spread fingers, four fingers, and these are three thumb. But and these are the wand shapes. These are hand shapes, and these are orientations, palm orientation. In the palm orientations, forward or upward. So these are upward palm orientation, and right hand side these are forward palm orientation. And this is specify hand black, sir, like hand two shapes, orientation, white and sir back side of hand. This specifies in the pictures, like sir, These specifies the palm orientations. And the next is the location. Location specifies the position of the hand, like top of head, forehead, nose, below the nose, lips, up arm lips, teeth, shoulders. By optional, if we did not specify the location of the hand, uh, arm chest is optional location of the virtual human character. These are the signs like arm close. These are the arm touch, and this symbol is arm interlock, and this is for arm cross sign. These are the movements. So these movements are upward and forward. These eight directions, upward movements, and these are forward movements. Forward up direction, forward down direction, and these 45-degree and 60-degree angles movement. And this is also up and down. These both signs are working similar. If the speed of the signer is slow or fast, for these two symbols, for fast, and this symbol for slow sign. If the action is repeated for 2 times 3 times, for these signs, we don't need to repeat the coding. With We can use only one symbol plus this symbol. If the sign is repeated for 2 times, we can use this. Movement can be circular form. Movements can be upward in the circular form and can be in the forward. For the upward direction, these movements are used, and for the forward movements, these symbols and these symbols are used. And these symbols are used for hands movement, only hand movements, fingers movements, like these, only finger movements, not hand movement. uh, Two-handed signs, if we want the make the sign for two-handed, this symmetry operator vertical and horizontals are needed. But if we want to make the sign only for single hand, then these up arm simper vertical and horizontal is not needed. Ham simper, this symbol is joined with this bracket parameters, and two-handed signs, left hand side and two hand side. If both hands functioning are different, then these workings are separated with this symbols, harm plus sign. Non-manual features, body, like RL, rotate left, rotate right, turn left, turn right, TF, turn forward, turn, sorry, tilt backward, and shoulder, like upper left raise, upper right raise, both raise, left shoulder hunch forward, right for shoulder hunch forward, both shoulders shrugging up, down, right, both. And head movement, like nodding up to down, shaking left to right, right, shift SL, turn left, TR, turn tilt right. Similarly, nose sign, wrinkling nose, winching nose, white nostrils, eye gaze, from from the eyes expressions. Because deaf people cannot listen the voice, from the eyes expression, from the face expressions. The deaf people indicate that this people is angry, happy, like ad, towards address, for towards the signer on hand, hi towards the signer on right hand, towards the signer left hand, up, eyes up, down, left, ri right, no, no target, unfoxed, arrow rolling of eyes, left up, right up, left down, the right down, eyelids, specify wb, wide, both wide open eyelids, wide open right eyelids, left eyelids. So these are the non-manuals.
So, Anu, how many total signs
200.
are there?
सर सिंबल्स 200 सर.
200 सिंबल्स. सो
हाँ जी सर.
किसी एक सिंबल को चला के दिखा दो, कैसे आप इसमें डाल के और कैसे बनाते हो सिग्नल फाइल को.
सर मैं न्यू बना के ही दिखाना कि बने बनाए ਨੂੰ ਹੀ ਦਿਖਾ ਦਾਂਗੀ.
बने बनाए ਨੂੰ ਇਹਦੇ ਚ ਕਾਪੀ ਕਰਕੇ ਇੱਕ ਵਾਰ ਐਕਸਪਲੇਨ ਕਰ ਦਿਓ.
जी सर. So this is a signal file, and this is a comment section.
बेटा थोड़ा जूम कर लो.
हाँ जी सर. uh, sir, this is a heminosis symbol. We typed symbol like this is a ham symbol. This is a hand shape, ham orientation, palm orientation, breast start, left hand side finger symbol. This is a right. This is a close symbol, and this specifies location. Firstly, we write these symbols.
So in nutshell, I'll just like to conclude over here is that whenever we have a human video, right? So like Krishma was our Indian Sign Language interpreter we have hired in our project. So whatever the video sign she generates by recording herself, so Anu looks at that video and then record each and every gesture in the video through this tool, and write this code over here. So when this code is complete, so then this animation can be correlated with that video, whether that is the same one as it has been in the video or not. So if there are any issues, so we go on changing it till it imitates the human video. This animated video should imitate the human video. So this is the objective of the tool. So yes, Binod, any doubt in this whole tool? Can we move ahead? Dr. Rana, other team members?
No, sir.
नहीं सर, अब तक बहुत सही है, बहुत अच्छा है सर यहाँ पे।
Okay, so now I request Jaswinder to please continue because this is what Anu has explained. So she was developing this manually. Basically, this is the aim what we have to do. So Dr. Rana, Vinod, this is the aim that we have the human videos with us and we have to generate the signal text automatically looking at that human video. So now, Jaswinder, please, this is your turn to explain what next you have done.
Okay, sir.
Anu, okay, please continue now.
Sir, can you move a little forward? So Anu ma'am has already explained about the sign language, like basic what it is and everything. And what we tried to do, there were two parts. Sir, if you can move to the objective, so we can start from there. Yeah. So now, basically, we had four objectives to do, and the first one was collecting a parallel data set of Indian Sign Language videos and their corresponding animated videos. So for this, as sir has already told that we used the interpreter. We hired an interpreter for this project, Karishma, and we had a huge collection of videos. Like in each video, there was some action being done, like some aeroplane action is being done, or some alphabet action is being done, some hello, some thank you. Each action is being done. So first of all, what we had to do was we had to prepare a data set in which for each video, for each frame, we had to symbolize like what it is that that frame is representing, what that person is trying to explain in that, using the Hamnosis code. So this was the work done by Jaswinder. So sir, if you can show the Excel sheet, then I can. Yeah. Okay. So as you can see, here we have an example video of liter. So you can imagine that we have a video, an MP4 video, which is depicting a person showing the like the action, the ISL action for liter. And now what is the manual work in this that Jaswinder has done? She has done the labeling for all of the videos that were there. So in all of the videos, supposing there is 60-second video, so there are 60 frames. So for each frame, then we have to depending on how many frames there are per second. There are 30 frames per second. So for 60 seconds, there are 60 into 30 frames. So for each frame, we have to write whether that particular, or like ma'am has said that there are 200 symbols. So for each frame, whether that symbol is present or not present. So as you can see, you can assume that the columns, that the rows that have been left empty, they are zero and they are not present, and the ones that have been marked one, they are present. So as you can see that out of all these, mostly they are not present, like it is can be considered as a sparse matrix, so it is not present. And only some of the symbols in each frame are present. So this was a huge tedious task to do, because as you can see, there are so many videos, and for each video there are so many frames, and we have to do the labeling for each and every symbol, whether it is present or it is not present. So we have a huge database like this, as you can see. This was the first part of the project, which was done by Jaswinder, but it was like a tedious task, and it was all manual work. There is no automation in this. You have to look at each frame and decide whether this particular symbol, what that action is, and whether it is present or it is not present. So this was the first thing we have to do.
And Rohan, I think 120 columns are there, 200 columns are there corresponding to
Yes.
each symbol, what Anu has
Yeah,
explained.
for each symbol we have mentioned whether it is present or not present in a particular frame for all the videos. And
Okay, so because Binod was saying that we can automate it. So I think you have already tried, and what are the challenges you have faced in it? Can you kindly explain?
basically what this work is, this cannot be automated because you have to a person has to look at this and decide whether this symbol is present or not present. There is no way that this work can be automated because this can be considered as a training data set. So training data set we have to prepare manually, and finally we can when we do the prediction we can decide whether we get some results up to a certain accuracy. But this is the training data set, and data set has not it is not given to us. It has to be made, and this is how we make the data set. Each person has to sit there and look at it whether this in this particular thing is present or not present. There is no way this can be automated.
Moreover, we were discussing that if the sequence can be added over here, I was discussing with Binod as well. So, will there be any benefit of adding the sequence of the movement of the gestures?
So there will be benefit only up to a limited extent because supposing if we add the sequence, the problem will be about the new videos. So so all these videos will whatever data we have already, it will work very well on that. But the problem is still remain on the new videos. Like if we have a new action, something like that, so previous sequences are of no use for that. So because each video has its own unique sequence, and that cannot be used from the previous sequence. Like there is no machine learning part in this because it is like 100% accuracy is required for this thing. That is the problem.
Yeah, Binod, any
So
question on this part? Because yesterday we have discussed on this.
Sir, I have a question in each frame. Does each frame have different symbol like marking here in the Excel?
yes, each frame has different symbols. Like a symbol may be present in one frame, but it may not be present in the next frame. That is the question.
No, I have the question that if it's in a frame, there are multiple symbols that is representing by a person.
Yes, there are definitely more than one symbol which is present in each frame.
Okay. Uh, suppose in a frame, our hand like our hand symbol is shown there. Then there could be, I think, a simple single sign. Suppose there is two finger or three finger. I think like this sign could be there.
See, basically there are different parts to the hemnosis structure. There is location, there is orientation, there is shape. So for each of these parts, there is some symbols corresponding to that. So for orientation, there is some symbols which are applicable to that particular frame. For shape, there is some symbols which are applicable to that frame, and so on.
Mm,
We have
uh,
200. So among 200, we are choosing that which are applicable on this
Total,
particular video.
but there are categories. So supposing if I'm making a shape of C, so depending on where that C is positioned, whether it is near my head, whether it is near my shoulder, so that is the location. And then I'm making a C, so the shape will be also there. And if there is some movement along with that, so some movement will also be represented. So that is that all this is in a single frame I'm talking about. So there are multiple columns for each frame.
okay, yes, thank you. That doubt has been clear. So can't we decrease this column?
No, there is no point in decreasing the column because that will only lead to you can make a valid signal file, but that will not represent actually what the person is portraying in the human video. So you have to keep each and every column here.
I think we can mark them like one, two, three, four.
Yeah, if you can do that, but then you need to create a dictionary to remember which what is one, what is two.
Yes, because labeling that would give this frame easily that we can train
Yeah,
train data easily.
I don't think it will make a difference, but if it helps you, you can label it as 1, 2, 3 and create a separate dictionary file for that if that helps you.
Yeah, we have to create a dictionary for labeling, and when we label that on the training of these frames, we could get easy formation.
Okay, okay, fine. If you can try. Anything else?
Should I share the presentation now back?
Yeah, yeah, sure.
Yes.
Is it visible?
Yes,
Yes.
sir.
Okay.
Okay, so this is a proposed methodology that we are trying to do. So we have already separated the videos into frames, and now the part is of prediction. So this is what I have shown you in the previous Excel sheet. This is the manual work that has been done. So now this can be considered as a training data set. So this data set has been input into a deep learning model, and now what we try to do is, supposing we are given new videos, we will split that into frames and try to predict whether, using on that frame, like this is the basic prediction part, that whether each symbol is present or not present in that particular frame. That is the main, like what is the machine learning part of this, whether each symbol is present or not present. Till now you have seen, like this is basically a binary classification problem. So whether it is present or it is not present, that is the main problem in this. That is simple, that you can use libraries for this to predict this. The added thing in this is that this is, like, we have multiple columns, we don't have a single column, we have multiple columns for this. But that is also not very challenging part. We can solve that easily. So sir, can you move forward? Yeah, so as I have said, that this is the first part is the tag generation. So we have an input video file, and then what we have to do is we have to generate the tags from this. So this is the prediction part. So supposing we are given a video, what we have to do is, for that video we have to make a signal file. So um, Anu ma'am has shown you one software, I think, before. In that software, what is done is, basically we enter the signal code. So ma'am has copied the signal code, and she has played it. And so basically, the avatar represents whatever the signal code has done. Signal code is trying to do. Signal code is basically like HTML code only, but it is used for specifically for sign languages. So one thing is there, that in the signal code, very important thing is sequence. So if the sequence is incorrect, then the software will say signal invalid. So one thing is that you need to predict the tags with certain amount of accuracy, and then those tags should be in particular order. If they are not in order, the signal file will not play. So that is the main thing, because uh, for simple videos, it is not that difficult, but the videos get complex. Then there is movement after movement, and there is sentences forming in each some video. So, and one of the major problems is that there are two hands. So there is no way till now to differentiate, like, which movement is of right hand and which movement is of left hand. So in the in the Excel sheet also, there is, there is specific columns for left hand, and there is specific columns for right hand. And there is no way to differentiate right now, like, which if a person is doing right hand or left hand movement. And and this is the major problem in this. The tag generation is simple, like machine learning using libraries. So if you can move forward. The major part is, even if we get some certain amount of accuracy with this, then the problem is actually the sequence. Like, the sequence should be 100% correct for the signal file to play. So if you can move forward to next part. next part. Yeah, so these were the frames, and for each frame, um, yeah, for each frame you can see you need to, the person is doing some action and we need to label it manually. You have to look at it, what the person is doing, where his location is, and what he is doing, what the action is doing. Then we need to and we need to label it. So yeah, so now you can see, so above where it says manual, you can see there is the Hamnosis code that we have entered. So corresponding to that, there is the signal text. So this is the main thing which we are focusing on. We are not focusing on the Hamnosis, the Hamburg notation. We are focusing on generating the signal text basically. So sir, if you can just stay with that. Yeah, so here you can see that there is, this is one very simple code. So there it says ham flat hand, ham finger, o, ham palm, ham shoulders. So this is the different symbols that are there in this video. So what we need to do is we need to generate this text. Our final goal is to generate this sort of text automatically. So for that, our input video will our input video will be given, and we will predict like this ham flat hand. Our model will say that okay, ham flat hand is present. Our model will say that okay, this one is present, ham palm is present, ham shoulder is present, ham beside is present. Okay, one thing is our model should be able to predict with accuracy that these tags are present. The second part is that we need that these should be in same order, which is the valid order. This is one of the main challenges of this project. This is a difficult one because each of the videos is unique, and even this is for simple one hand movement. So when what happens is when there is two hand movement, then there is no way to tell that which is the left hand part and which is the right hand part automatically. Sir, if you can move forward. Yeah. So next. So this is like the training data set which we have created. Ones and zeros are there. So yeah, this is a training data set, and similarly, when we are trying to predict for a new video, we have like a similar sort of result, whether each of them is present or not present. So for final video, there is one point to like remember is that we need to combine the output for each frame and make a single signal file. So yeah, so this is the arrangement of generated tags. But there are basically two approaches I have described here. So one is using simple nearest neighbors concept. So for nearest neighbors concept, we actually don't even use the frames here. This is simple. A video is mapped to a signal file, and we use the nearest neighbor concept to predict whether if that video has already been seen, then it will simply map to its nearest neighbor, and we will get the correct result automatically. So this is basically, for new videos it will not work. For this is basically like you can say overfitting, because we are working on the same like the exact same data set we are there. Only those videos will give us good results. The new videos will not give us anything. Okay, so next. So this is the simple 2D CNN model we have made. You can read about it easily. I don't think I need to focus upon this part. So you can do this, and we have already done. But the main problem is on the sequence part. We can generate, like we can predict what tags are present or not present. Okay, so we can predict the signal tags which are present. So this is one part. So the next part is the tag arrangement. So this is the thing. So tag arrangement, one thing we can do is we can try a brute force approach. So okay, we can say we can try. Suppose we have 4 tags. So but we don't know like what is the exact like sequence for those 4 tags, which is the valid sequence. So one thing we can do is we can try a brute force approach. We have already done that. We have a small Python script which rearranges the tag every time, then whichever is the like rearranges the tags and tries for each tag whether it is a valid signal file or not valid signal file. Okay, this is a very simple concept. And then the problem is, this is supposing we have 100 tags, which, and there are some videos which has many tags. So as you can see that it is very difficult to try a brute force approach for like this sort of thing. And even if that brute force approach works, there is no guarantee that there can be like more than one valid sequence for each file, and there is no guarantee that that is the correct valid sequence which we want. The video may play something, but it may not necessarily be what we are trying to get it to play. So the next part is, what we can do is we can, so suppose we can make like a dictionary and block arrangement. So we can say, okay, this tag is part of like shape, okay, and this tag is part of orientation. So we can pick this and put it there, like sort of fill in the blanks one. So we can put, okay, so this part is there for this part is there for this, and we can use sort of a fill in the blanks approach. And this works to an extent, but then inside those orientation one, like there may be internal ordering which is not correct, and so on. And even the major problem is of the left and right hand tags. So whoever will continue this project will have to start like from a new approach, most probably, to uh, to solve this problem. To first of all, you have to detect like which are the left-handed tags and which are the right-handed tags. Only then this problem can be solved completely. So this approach works to an extent, but only for basically for one-handed videos, and that also the internal sequencing, which is not correct. Yeah. So basically, I have explained whatever is the problem with this and what is the discussion of this. If there are any more questions, you can ask.
नहीं, थैंक यू रोहन, बहुत अच्छा काम किया तुमने यार. एंड यू एक्सप्लेन्ड वेरी, बहुत अच्छे सिंपल ढंग में. अब विनोद,
Yes, sir.
काइंडली सजेस्ट हाउ वी कैन प्रोसीड.
Yes, sir. Repeat again.
Kindly suggest how we can proceed.
Sir, we can make this we could first of all, I think we have to generate a training set again,
Hmm.
and we will generate a training set in a level.
Mhm.
Then we have to try to make collect a larger testing set.
ठीक है, कोई इशू नहीं है, कोई इशू नहीं. विशाल सर, बेसिकली क्या है, अभी थोड़ा टीम को टाइम देते हैं, 1-2 दिन का. लेट देम डिसाइड, लेट देम डिस्कस, एंड कोई हमें कोई हेल्प चाहिए तो हम है ना रोहन से डिस्कस कर सकते हैं.
हाँ हाँ, बिल्कुल बिल्कुल सर. और वैसे भी ना, अगर कुछ डेटा जनरेशन के लिए भी कुछ हेल्प और चाहिए होगी, तो अभी हमारे पास एमसीए के स्टूडेंट ट्रेनिंग के लिए आ रहे हैं.
ओके,
सो आई कैन एंगेज दो स्टूडेंट एज वेल अलोंग विद योर टीम.
बहुत अच्छा. अच्छा, मेजर अल्टीमेटली ऑब्जेक्टिव हमारा है फेशियल एक्सप्रेशन भी ऐड करना है ना इसमें.
जी जी जी, इसमें फेशियल एक्सप्रेशंस का जो हमें ISLRTC, जो कि गवर्नमेंट ऑफ इंडिया का इंस्टीट्यूट है दिल्ली में, तो वहाँ से जब हमने सिस्टम को हमेशा ये हम लोग डेमो देते हैं, तो वो यही कहते हैं कि इसमें फेशियल एक्सप्रेशंस मिसिंग है. बिकॉज जब भी साइन लैंग्वेज की बात करते हो तो फेशियल एक्सप्रेशंस 80% वर्क करते हैं, तो हमें फेशियल एक्सप्रेशंस को भी इसमें ऐड करना पड़ेगा.
ठीक है, ठीक है, ठीक है, ठीक सर. और ये
तो
हेल्प
डॉक्टर ललित, एनी इनपुट्स फ्रॉम योर साइड प्लीज?
Sir, Rohan has done very good job, but the problem that he has discussed, that 200 signs are to be separated actually for the left hand and for the right hand. These are the separate signs that are that must be recognized from the video, and that is the biggest problem, I think, because in sign language we make use of both the hands, not the single hand. There are very little signs which are used in sign language with the single hand. So this problem must be solved either making use of bigger and bigger training data, or there might be the combination of signs. We should invent our signs uh, which are used for both the hands simultaneously, not the separately with single hands. Uh, that I think it might be possible. Not sure how much success we will get, but it might be one of the solution. So rest, he has done a very good job, though.
Yeah. So, Dr. Anna, one more thing that we need to do over here is, as this is a third-party component that we are used over here, Hamnoberg, this system. So here the avatar is, this is not Indian, right? So the costumes, the look and all. So that was also an objection over there. So one of my PhD student, Dr. Ajit Kumar, who is Registrar Modi College, his son is working in Bangalore, and he is a trained designer. So I had already requested that if he can change the avatar costumes and all. So we have identified some portion where this modification can be done. So as you people are sitting near to Thapar and he is staying near to Thapar also, so if you can depute one student who can go to their home, sit along with that guy, and then avatar can be modified.
ठीक है, good.
So that will be then our exclusive system can be there.
ठीक है सर, बहुत अच्छे से.
Okay. And Rohan, so will you be having time these days if you can just get the guidance from Dr. Rana and write the research paper for ICA journal, what you have already done, because that is not published yet, I suppose.
Okay, sir, I will talk to Dr. Rana about this.
Because he's the only expert person I know that we can publish our work in SCA journal along with him.
Okay sir, I will help Rohan also.
Yeah, yeah. So anyhow, I think all the doubts are clear and system is clear to all.
Yes, sir. Sir, talk to ma'am Anu ma'am so in future so that I could get about this what she is doing.
No issues, no issues. She is always available. So I will share. I think she is in the group as well. So whenever
Oh,
you have any doubt, you can just talk to her also. That's not an issue.
sir, I want to learn about all the symbols so that I could get easily on that. So
So what I can do is over here is that can be a repository also. I will request Anu to record the demonstration of this tool in an exhaustive way, okay, in the form of video, and then she will be sharing with us so that once you can have that video along with you forever, and whenever you have the doubt, you can consult her anytime. That will be fine.
yes, sir. Yes, sir.
So then I think we should leave the meeting. Thank you, Rohan. You have done wonderful job, and I think we will be needing your help again and again for completing this project. So Anu, you will be assisting Binod and all the team members whenever they are requiring. So
Yes,
Jaswinder,
sir.
we will
Yes.
be requiring your efforts also whenever we require. So I know you people are preparing for your future assignments. So we will not be disturbing much, but in between, if we require any help, so we will be disturbing you. Okay, Rohan, Jaswinder?
Okay, sir, no.
And I would like to tell you that Jaswinder and Rohan are the toppers of the MTech Artificial Intelligence in our university. Jaswinder is the gold medalist, and Rohan is after that. So
That's great.
congratulations to you.
Congratulations, both of you, dear.
Okay, thank you very much for joining.